Example 1, prove that for all n a natural number, 3 is a factor of 4 to the power of n minus 1. So we're going to go through our steps. Number 1, okay. Prove true for n is equal to 1. Okay. So is 3 a factor of 4 to the power of 1 minus 1? 3 is a factor, 4 take 1 of 3. So that's true. Okay, so 3 is a factor of 3. Number 2, assume true for n is equal to k. 3 is a factor of 4 to the power of k minus 1. We're assuming that to be true. Okay? Now we need to show it true for n is equal to k plus 1. So what we're going to do is, anywhere you see n, you're replacing it with k plus 1. So you get 4 to the power of k plus 1 minus 1. Now here I'm adding my powers, so that means I was multiplying and the bases were the same. So that's 4 to the power k by 4 to the power 1. Now that 4, you're going to replace it with 3 and something. Okay, so I'm interested in 3 being a factor of it, so I'm going to replace this 4 with a 3. Okay, so I get 4 to the power k by, how do I make 4? Well, 3 plus 1. Okay, so I haven't changed my sum at all. 3 plus 1 gives me 4. Now what you're going to do is you're going to multiply that 4k, you're going to distribute it into the bracket. Okay, so you're going to get 3 by 4 to the power k, and you're going to get 3 by 1 minus 1. Okay, sorry, you're going to get 3 by 4 to the power k, and you're going to get 4 to the power k by 1. Sorry, that 4 to the power k goes there, and 4 to the power k goes there. Sorry, girls. Okay, now you're going to have a look at your assumption. Okay, so I have 3 by 4 to the power k, and here I have 4 to the power k minus 1. Now we know 4 to the power k minus 1, we assumed that true. So 3 is a factor of this, and 3 is a factor of this, because 3 is outside the bracket. That means 3 goes in there. Okay, you're multiplying it in, so that means 3 is a factor. Okay, so all you have to say here is this part is divisible by 3, and this part is assumed divisible by 3. Okay, so we assumed that up there. Therefore, the whole thing is divisible by 3. Okay, so that means we have to do all the words again now. Alright, so exact same finish that we had to the last one. What we say here, therefore, true for n is equal to k plus 1. This is true. Now step 4 is, if it's true for n is equal to 1, then it's true for n is equal to 1 plus 1. Okay, so let's just write out our step 4. Just going back over here. So we say true for n is equal to 1 must be true for n is equal to 1 plus 1. True for n is equal to 2. Must be true for n is equal to 2 plus 1, etc. Therefore, true for all values of n. So these divisibility ones are definitely a little bit nicer. So you're just trying to show that you have the assumed part in your answer and you also have something that's definitely divisible. Okay, so like 3 by that is definitely divisible by 3. Have you any issues there? Okay, let's do another example. So prove that this is divisible by 7 for all n is a natural number. So all natural values of n. So we're going to prove it true for n is equal to 1. So we get 8 take 7, which is 1, 1 plus 6, which is 7. Okay, and 7 is a factor of 7, so true. Okay, so it's true for n is 1. Assume true for n is equal to k, so that means 7 is a factor of this thing. We're assuming that to be true. And now we need to show it true. So show true for n is equal to k plus 1. So let's replace our n with k plus 1. Now, that 8 to the power k plus 1 is 8 to the power k by 8 to the power 1. Minus 7 by k is minus 7k, and minus 7 by 1 is minus 7 plus 6. Don't put them together. Okay? Remember, you need to use your assumption. So that means I need an 8 to the power k, a minus 7k, and a plus 6 in my answer so that I can use my assumption. Okay? Now, just like we did down here, we're changing 8 to be 7 and something. So in this case, it's 7 plus 1. If it was a 9, sorry, if it was I'm interested in 7. So, yeah, sorry, this is an 8. It's going to be an 8 take 1. Sorry, 7 plus 1. If I was doing divisible by 7, yeah, okay. So sorry, if this was a 6 here, if this was a 6, you could do 7 take 1 to give you the 6. Okay, sorry, that's what I'm trying to say. You're always using what you're doing is a factor, so 7 is the factor. So in this case, I'm replacing the 8 with 7 and something, so 7 plus 1. Okay, minus 7k, minus 7 plus 6. Here then, I get 7 by 8 to the power of k, and I get 1 by 8 to the power k. all you're going to do now is you're going to rearrange it slightly. Okay, so I want the assumption to be together. So 8 to the power k minus 7k plus 6. Okay, minus 7k plus 6, and then I have 7 by 8 to the power k and minus 7. Okay, I have those two things. Last step is I would just factorize out the 7 out of both of those. Okay, so leave this and take out the 7. 8 to the power k minus 1 is what you get. Okay, you're left with that. Now, this I assumed it true, and this is definitely true because 7 divides into that. 7 is a factor. Okay, so 7, that's divisible by 7. Okay, this thing is assumed divisible by 7. Therefore, the whole thing is divisible by 7. That means it's true for n is equal to 1. Sorry, k plus 1. It's true for n is equal to k plus 1. Then you go to your fourth step and say, okay, true for n is equal to 1 must be true for n is equal to 1 plus 1. True for n is equal to 2 must be true for 2 plus 1, etc. True all values of n. Is that okay?